I'm HW Xing. In this project, I developed a classifier using the UCI banking marketing dataset with the objective of maximizing ROC AUC while ensuring that the model is well fitted. As required by the rubric, I will directly address the two discussion promotes: what I did to improve the performance of my regressor, what I did to assess and improve the fit of my regressor. The dataset contains approximately 37,000 training observations and is moderately imbalanced, with around 11 to 12% positive cases. Because of this imbalance and mixture of numeric and categorical features, careful modeling and validation were required. Given the mixture of categorical and numerical variables, I selected CatBoost as my primary models. CatBoost is particularly appropriate for this dataset because it handles categorical features natively. It performs strongly on structured tabular data. It reduced the need for extensive manual encoding. This choice allows the model to capture nonlinear interaction between customer behavior and financial variables. To improve predictive performance, I engineered several meaningful features directly in the notebook. I convert months into numerical feature called monthsNum, create balance per age to normalize the financial status related to age, created is bankrupt to indicate the negative balance, created is active client to capture engagement patterns, created P-days never to indicate customer never previously contacted, transform P-days into categorical bins using PD-code to capture nonlinear effect. These features were designed to expose dominant, relevant patterns that boosting models can exploit effectively. Since the dataset is imbalanced, I used CatBoost built-in imbalance handling mechanism. Auto class weight equals to square balanced. This automatically adjusts class weight based on the frequency and improves the ROC AUC on imbalanced data without manual weighting. I tuned key hyperparameters to balance the model flexibility and generalization, like the code showed. These parameters were selected based on the cross-validated AUC rather than the arbitrary choices. The final cross-validated ROC AUC stabilized around 0.80. To properly assess generalization, I use stratified K-hold formula. The stratification ensured that each fold preserved the original class ratio. For each fold, I trained on the training split. I evaluated the ROC AUC on validation split. I recorded fold level AUC values. I then report the mean AOC across folds, standard deviation of AUC. The relatively low standard deviation indicates the stable performance across different partitions of the data. This directly satisfies the requirement that performance to be appropriate validated. Although I set a large maximum number of iterations, I enabled the validation-based early stopping using early stopping round and use best model equals to true. This ensured that training stops once the validation AUC no longer improves. Early stopping prevents the model from memorizing noise and therefore improves generalization. I deployed a learning curve to assess the model fit. The learning curve shows that the training AUC remains close to 1 across the sample size, while the validation AUC increases gradually from approximately 0.73 to around 0.77. This indicates that the model has high capacity and fits the training data extremely well, while the generalization performance improves with more data. The persistent gap between the training and validation AUC suggests some degree of variance, but the upward trend in validation performance indicates that the additional data helps reduce this gap. Overall, the model strategy reflects deliberate bias variance control. Increased steps and nonlinear interaction reduce bias. Regularization through 12-leaf regs, subsampling, and early stopping controls variance. Cross-validation ensures robustness across data split. The final model achieves stable RUC and AUC around 0.8 while maintaining consistent validation performance. To summarize, to improve performance, I selected CatBoost for mixed tabular data, engineered dominant relevant features, used built-in class imbalance handling, tune model capacity and the regularization parameters. To assess and improve fit, I apply 5-host stratified cross-validation, report mean and variance of AUC, use early stopping to prevent overfitting, deployed a learning curve to analyze bias variance behaviors. The final model achieves strong predictive performance while demonstrating stable generalization. Thank you.